Hi everyone. Um, so, good morning. Paper one discussion. I gave you. Actually, I was waiting for the others. They are yet to come. By the way, I'm going to start now. Um, I gave you there 10 short questions and 4 essays. So, as per the answers you have given within the given time, especially for those short questions and along with the essay questions, I picked some of the questions which are like uh, needed to be discussed. So there, I'm going to pick the first question as the modulus, the new syllabus model question number 2. There they say sketch the graphs of y equals modulus 4x minus 3 and y equals 3 minus 2 modulus x. There, this is the thing we are going to do in this paper class. We are going to revise the things with the question. So let us say here we are going to do the modulus inequality question in graphical method in particular because they have recommended to sketch the graphs. So we will be revising sketching graphs. We'll be revising on arranging data sets for the modulus graphs, then how to solve modulus inequality, then how to solve modulus inequality when they are giving a different question other than the graph. So in particular, the substitution method. Right. All are clear for what we are going to do. So let's start. Question number 2. Question number 2. There, the graphs are y equals 4x minus 3 module. Y equals 4x minus 3 module. So the data set you need to have here, uh, first, it is about the limiting value. So the modulus function, when you have the modulus function, what is the meaning of the modulus function? You only have to have the plus outputs for all the plus and negative inputs for your x value. Function should have plus value only. There, you know that from the inequalities, everything depends on the limiting value. So here, what is the limiting value? Is 3 by 4. Limiting value is called to be the value of the input or the value of x when the expression gets to 0. So I got 3 by 4 for x when by making 4x minus 3 to 0. All right. This is how you analyze the data set. You need to analyze y where x is 3 by 4, x is greater than 3 by 4, x is less than 3 by 4. When x is 3 by 4, y is 0. When x is greater than 3 by 4, let us say 1 plus. So you don't need to do anything, just let it go. When x is less than 3 by 4, let us put 0 there. So once you put 0 as for one value from that region, this is going to be negative. So you need to make sure that to get it multiplied by negative. Once you make the input from this particular region, if the output gets to negative, you have to have plus output for the modulus function. So you have to get it multiplied by minus. So that is it. It is going to be y equals minus 4x minus 3. Y equals minus 4x plus 3. That is how you have to do that. Clear? Then the next that is done. Y equals 3 minus 2 modulus 6. Y equals 3 minus 2 modulus 6. Y equals 3 minus 2 modulus 6. 3 minus 2 modulus 6. So here the limiting value is 0. Here the limiting value is 0. So you have to analyze the data set with respect to 0. So x is 0, x is greater than 0, x is less than 0. When x is 0, y is right away 3. Alright. y x is greater than once x is greater than 0, let us put like 3. It doesn't matter for the function inside the modulus, you don't need to do anything, just let it go. Y equals 3 minus 2 x. When x is negative, let us put like minus 3, it is minus, you have to get this multiplied by minus whatever inside the modulus, that minus with the minus inside the 2, so it is going to be plus. So y equals 3 plus 2x. That is it. Those are the graphs. So we have to sketch the graph. Sketch the graph. Y-axis, x-axis, origin. Let us first go for the limiting values. 3 by 4, 0. And here 0, 3. We have to deal with 3 by 4 and 3 next. Then I think like 3 as this much. That is better 3. Because we are sketching, right? We are not drawing. I mean 3 as this much. It makes me easier the process on sketching the graph because I have to have 3 by 4 and 3. 4x, 3 by 4 and 0. So 3 by 4. 3 by 4. 3 by 4, right? 3 by 4. Through that, I am sketching the dotted line to distinguish the region. 3 by 4, 0 is, this is going to be the limit, turning point. Greater than 3 by 4, 4x minus 3. So 3 is this much. 4x minus 3. Y equals 4x minus 3. Less than 3 by 3 by 4. Y equals minus 4x plus 3. Y equals minus 4x plus 3. That graph is done. Now the other graph. 0, 3. 0, 3 means here. 0, 3 means here. So let us take the graph. Greater than 0 is 3 minus 2x. Greater than 0 is 3 minus 2x. By the way, here we have like a struggle because 0, 3 is the turning point, and at the same time, when x is greater than 0, it is 3 minus 2x. The intercept is the second data, but the intercept and the turning point are the same here. That is the struggle, knowing that to sketch a straight line, we need 2 points in minimum. You have to have one more, and that is going to be obviously, as we learn in sketching the graphs in foundation course, the cutting point of x-axis. How to have the cutting point of x-axis here? By making y 0, 2x3, x3 by 2, x3 by 2, x3 by 2. So this is going to be 3 by 2. You don't need to mark any other value other than the cutting point. So the graph is y equals 3 minus 2. Y equals 3 minus 2x. When it is greater than 3 by 4. When it is greater less than 0, 3 plus 2 is. So you have to have the cutting point on x-axis by making y 0 minus 3 by 2. Minus 3 by 2. So this is minus 3 by 2. Minus 3 by 2. So the graph is y equals 3 plus 2 is, right? So what they ask here as the question, hence or otherwise find all real values of x satisfying the inequality. 2x minus 3 plus x less than 2. 2x minus 3 modulus plus modulus x less than 3 plus modulus x is less than 3. There, the thing is this. The graphs we sketched are the graphs for the modulus 4x minus 3 and modulus 3 minus 2x. By the way, we have to use these graphs to solve this particular modulus inequality. There you have to like be tricky. So this is what you are going to do. According to the formats of the graphs, I would like to take this modulus x to the other side. Then I can like match one side of the inequality to this graph and the other side obviously with this. Then we can go for the substitute. So I'm going to bring modulus x to the other side. So 2x minus 3 less than 3 minus modulus. By the way, by looking at these two, you can like clearly see 2x has like in our graphs, it is not 2x but 4x in our functions. In the inequality, you have 2x. In the functions given, we have 4x. Because what we all know is to solve by using these graphs as we have sketched those graphs. Then for modulus x, we have 2 modulus x. So what you need to do, it is like x has become to 2x, but in substitution, you never use the same variable in both the sides. So you are going to substitute like this. By substituting, x equals to t, this is going to be uh, the new inequality after you substitute x equals to t. So this is 4t minus 3, 4t minus 3 less than 3 minus modulus 2x is 2 modulus 6. Sorry, modulus uh, x is 2 modulus 2t, which is 2 modulus t. Now you can see the connection between your graph with a different variable. It doesn't matter. So this is y is plotted against x. In the same way, y had it been plotted against t, it would have been the same graph. The variable doesn't matter. The input variable doesn't matter. That is. So this is what you need to have. C minus 2 modulus graph should be greater, which is this. So when you have cutting point, before to the first cutting point, our 4x minus 3 modulus graph is right in between. So the requirement is satisfied. So afterwards, the second cutting point again, it doesn't valid. So this is the reason you have to say it. Let us name as P and Q. P is easily can be taken by the graph. So you can say by graph, you can say by graph xp is 0. Now for Q what you need to do, you have to solve these two graphs. 3 minus simultaneously you have to solve y equals 3 minus 2x, y equals 4x minus 3, make them equal. 3 minus 2x equals 4x minus 3. So 6x going to be 6. 6 is going to be 1. 6 is going to be 1. So what about the solutions of this particular graph is going to be, so by using our graph, we are going to solve so accordingly. So this is about, we have converted the x inequality they have given into the t's by using the substitution. There, by observing this, you can see, since the found x's are 0 and 1, therefore the solution of, therefore solution of, therefore solution of, we have some other ways of solving these two. This is like basically I'm teaching you. Therefore solution of 4t minus 3 less than 3 minus 2t modulus is a solution set of, it is like better. What is the solution set? Actually matching with the x's, you can say for this it is between 0 to 1. So t is between 0 to 1. Again, the thing is, you know that to have the solution of this, it is going to be like back to x, right? As you have substituted x equals t 2t, x equals 2t, as you have substituted x equals 2t, then oh, to have the solutions of x, what you need to do, you always have to, yeah, get the t, answers of t multiplied by 2. So you have to say, therefore solutions of, therefore solution set of 2x minus 3 modulus less than 3 minus x modulus is, yes, x is between 0 and 2, because you have to get it multiplied by 2. Is that clear? Because x is 2t. So for the solutions of t, it is going to be 0 to 1. What you did, you know that 2t is x. It means that 4t is x. 4t is 2x. You are back to the original question. And to have the x answer, it is always t multiplied by 2. That is how we got the answer. Is that clear? So in making the short question, you know that you only have half of an A4. There you have to manage that particular space. This is like explanation. So I mean, with the practice, you can manage the time and the space. Right. So you can do the corrections. I'll give you some time. All okay, right? So, yeah. Now, question number three, pick the limits to revise limits and the mistakes you have done in it. In solving a limit, you have to apply properties appropriately, otherwise you will have no marks. That is why. So in question number three, that is not a hard limit actually. That is like a moderate question. Limit extends to zero. Limit extends to zero. 1 minus cos 4x plus x sine 3x. 1 minus cos 4x plus x sine 3x over x squared. So obviously by looking at this question, you can say whether it is algebraic uh, limit or trig limit, which are the two basic limits we have in A level. By the way, by looking at this particular limit, you can certainly say it is trigonometric. So, in solving trigonometric limit, this is going to be that issue we have where we cannot do the direct substitution. In the direct substitution, where we have that not defined value. So, what is that? So, trig limit extends to 0 sin of x of x, which is, I mean, when you substitute direct, it is 0 over 0, which is not defined. That is what the case was. By the way, by using the geometric method, we proved that it is 1. So this is what you have to search for here. Otherwise, uh, check by directly substituting. X0 and 1 minus cos 0 is 1, 1 minus 1 is 0. 0 into sin 0 is again 1, again, sorry, 0. So 0 is in the numerator. X squared obviously is 0. So 0 is at the denominator as well. So 0 upon 0. That is. There, what you have to do is, you have to search for the sin x of x's and get them substituted to 1. That is what you have to do. There, I prefer this to make 1 minus cos 4x separate and x sin 3x separate, right? And you have x squared, which is as the division now. So let us separately divide. You know that in maths, when you have a plus b over c, you can write it down as a over c plus b over c. You can separate actually a division where you have an addition or subtraction in the numerator. So I'm going to, I mean, you don't need to write this down in the answer. This is for explanation. So the first step is, I'm going to separate these two. Limit x tends to 0. By trigonometry, what you need to do is, yes, in power reduction formula, which are regarding to double angle symmetry. Of course, it is going to be cos 2x into 2 cos squared x minus 1. There you can write down cos squared x as 1 plus cos 2x over 2. So cos 2x at the same time is 1 minus 2 sin squared x. There what about sin squared x? There what about sin squared x? Sin squared x equals 1 minus cos 2x by 1 minus cos 2x by 2. Clear? So trigonometry is here. So you have to know this trigonometry, otherwise you cannot even continue with like the other steps. Yeah, you can clearly see you have this format 1 minus cos 2x. So 1 minus cos 2x is 2 sin squared x. It means that 1 minus cos angle is 2 sin squared half angle. So 1 minus cos 4x is 2 sin squared 2x. So 1 minus cos 4x is 2 sin squared 2x. 2 sin squared 2x. That clear? 1 minus cos 2x, 2 sin squared x. 1 minus cos 4x, 2 sin squared 2x. Is about multiples. Right? So I'll get this divided by x squared after changing. Then you know that sum of a limit is limit of sums. So you can separate limits. Limit x tends to 0, x sine 3x by x squared. There you can cancel out x to x. Right. The next step. In the next step, now you can clearly see that Sine angle of x. There you have to like change accordingly. I mean, sine when limit x tends to 0, sine x of x is 1. By the way, once you have like sine 3x, sine 2x, you have to adjust accordingly. How I can take this 2 out? After taking 2 out, we have limit x tends to 0. Uh, Sine square 2x. Like, the issue we have 2x here. So you have to have also 2x here. That is the case. So altogether, since you have sine square 2x, you have to have 2x square. Had it been sine 2x, 2x. Sine square 2x, 2x squared. Sine cube 2x, 2x cube. Likewise. By the way, there is something. I mean, you had x squared only. You converted into 2x squared, which is 4x squared. So it is about balance. Dividing by 4, multiplied by 4. At the same time, please make, because the angle is 2x and not x. So please make it to 2. Then we can justify it after this step. How it becomes to 2. Then plus here limit as well, there you have sine 3x. So what you need to do is make 3x tends to 0. Then you have sine 3x over 3x, because the angle should be the same thing as what you divide there, right? So you got denominator divided by 3. So you have at the same time multiply, right? Then you can take the constant out, right? So the next stage equals, you have to justify this. What you did, you have to justify. How to justify? Because of that, when limit x tends to 0, limit 2x tends to 0, and limit 3x tends to 0. The two are tending to 0. Next step equals 2. Another thing you have to know is when you have a power of a limit, you can make the whole thing into power according to the properties. So it is going to be 2x tends to 0, sine 2x over 2x, the whole thing square, right? 2 and 4 also, so it is going to be 8. Then plus 4, and this is directly, I mean, 4 into, you have to have, you have 3 there. Then take 3 out, it is going to be just, is everything is 1. So 3 into 1. After that, you can say this is also 1, justify everything. 8 into 1 square, 8 into 1 plus 3 is 11. This is how you have to have this answer by following all the required steps. You can't miss anything, because in the marking scheme uh, you assign the marks for the steps, not only for the final answer. Clear? So please do the corrections. If you have any question, please don't hesitate to ask. Do the corrections. All right. So we are moving to, so in writing down your answers, I mean, in correcting your answers even, mark all the important points. So just after the class, this is how you learn. You can like pick 4 5 more questions and make your hard work on that. Then you can like revise and get ready. I mean, weekly for the exam question. Then only you have the practice in the exam, like nothing to think. Like, I mean, you have the practice and you are like in all the 3 hours completing everything towards the 100 marks, right? So, question number 4. Question number 4. Here I discuss weekly all the lessons properly through the questions. Right. Question number 4, it is about applications of integration. There are, you know that we have 2 applications, area under curve and volume by revolution. There, you have question number 4, volume by revolution. By, I mean, you are rotating by 360 around x-axis. To make that solid, you have to find the volume. It is not about the area under curve. By the way, it is about, as it is a short question, you have nothing to prove. You just have to apply the formula. Even you don't need to, you're not needed to sketch the graph because they have given the graph for the appropriate region. Even in sketching the graph, it is like, I mean, that is not needed even. And if you need to sketch this graph, you have like use differentiation. By the way, it is not needed. So let us directly go for the formula. So their volume equals pi x squared for the appropriate limits, right? For the appropriate limits. There, here, what about the graph? X over x squared plus 9 square root. So here volume is from where to where you have to have the solid with this revolution. 0 to 3. 0 to 3. It is from 0 to 3. 5 is here. Fx is x over x squared plus 9 square root. X over x squared plus 9 square root. So that is it. So take 5 out. Then you have 0 to 3. X squared over x squared plus 9 dx. It is a rational function. In integrating rational functions, we learned different methods. One goes for sure, you have to check for f dash x or fx, where you have the derivative of the denominator and numerator, but that is not possible here since the degrees are equal. So next you have to check for the partial fractions. That is also not possible because x squared plus 9 cannot be factorized. So the next thing is by lone division. Yes, that is going to be the lone division. But for special questions, it is like you can balance the thing. Here also, what you need to do, you have to add 9 and subtract 9 without harming the question. Then let us uh, separate like x square plus 9 now x square plus 9, which is going to be, just 1, nothing. I mean, nothing means just 1. So it is 1 dx minus 9 now. 1 of x squared plus 9 is 3 squared. Why I made it to 3 squared? Actually, by targeting 1 over sum of 2 squares with the variable and the constant, it is tan inverse. That is obviously why I made it. So x squared plus 9 over x squared plus 9 is 1 dx. Yeah, tan inverse. So minus 9 of x squared plus 9. So minus 9 was taken out. Then 1 of x squared plus 3 squared is tan inverse. That is why I made 9 to 3 squared by targeting the formula itself without taking any other steps. Right. This is going to be then, we have to apply the limits as well. 0 to 3, 0 to 3. Then after that, 5. What about the integral of 1 is x, 0 to 3. 9 now, integral of 1 over x squared plus 3 squared, 1 over a, then tan inverse x over 3. Tan inverse x over 3 from 0 to 3. Is that clear? because that is tan inverse x over 8. Once you have 1 over x squared plus a squared, the formula is 1 over 8 tan inverse x over 8. We have proven everything. So you can revise the things. With this question, you have to write down, I need to revise this in case you have forgotten, right? So phi out, 3 to 0 x is 3 minus 0, which is 3, minus 9 by 3 is 3, tan inverse 1 minus tan inverse 0. So it is obviously tan inverse 1 minus tan inverse 0. Tan inverse 1 minus tan inverse 0. Tan inverse 0. Tan inverse 0. Tan inverse 1 minus tan inverse 0. There is 5 and you can take even 3 out. So 3 5 out. Here you have 1 minus tan inverse 1 is 5 by 4. So 3 5 into 1 minus 5 by 4. They haven't given any radians. So, I mean, any units, radians. So, sorry, I mean the units. They haven't given like cubic units or anything. So, you don't need to put table. You can stick with this answer. Is that clear? Right. So, that is what you will surely have this question. So, when we talk about this model, you will either have both area under curve and volume by revolution. Or volume by revolution only. Normally in this syllabus, you will not have just that area under curve. You might have both or volume by revolution, right? So please get this done. All right. The next. Question number 6. Question number 6. So I'm moving to applied right. Yeah. Question number 6. Question number 6, they say a uniform rod AB is kept in limiting equilibrium with the end A on a rough horizontal plane and inclined at an angle theta to the horizontal by pulling by a light inextricable string attached perpendicular to the rod at NP. The rod and the string are in the same vertical plane. If the angle of friction between the end A and the rough horizontal plane is lambda, show that. So it is this. Right. So this rough horizontal plane. In a rough horizontal plane, the rod is in equilibrium, angling theta to the horizontal. By the way, you can't keep the rod equilibrium like this. So what you have to do is you have to have an external support. How they have given the external support? They have applied. So this state is A as they say. So this is B. They by a light inextensible string attached perpendicular to the rod at NB. Perpendicular to the rod. So here they haven't given you the other end of the string by the way. It means that you don't need, I mean, it is not important key exam. Got it? So that is what they mean. So you just need to mark the things and the force you need. That is it. They haven't given, so you don't need to specify that. And let us mark further. So this is 90 degrees. And let us mark weight in the middle. So it is going to be the weight. And what about the road length? Road length is yeah, they haven't given, but uniform road. So you can name it length ABB 2L. Let us say. So this is LL, right? Which is going to be LL as it is storage. Then the thing is in solving the questions which are for equilibrium of rigid bodies, what you have to do is in the free body diagram, you have to make the three main forces concurrent, meeting at the same point. There, this is what you are going to do. For sure, force is, I mean, the weight is vertical and you are sure of the tension as well. So you can name this as the point of concurrence. And you know that I haven't marked the friction yet. Marking the friction, it is F and the perpendicular uh, reaction as R. So obviously, for A, you have both perpendicular reaction and friction. So we are going to have the third force as the resultant of those these two. So by the way, I'm marking by a dotted line as I have marked already. If and now is going to be X. Clear? So that is the point of concurrence. Thereby you have A, B. I'm going to name this point of concurrence as C. So here you can see here C is the point of concurrence in free body diagram. All right. Now, actually, the easiest way in solving this is uh, the control. By looking at this, you can see the control here for ABC triangle. So you can see applying control. So you have two ways in solving friction question in particular. One is by resolving the forces and taking moments. The other one is by using control. So I'm going to apply control here. Since they have specified about friction angle. So obviously, what is friction angle? They have mentioned this is the limiting equilibrium. Obviously, exactly. In limiting equilibrium, friction angle is going to be the angle between the perpendicular reaction and the resultant of the perpendicular reaction and the friction. So obviously, lambda is this, which is the friction. So lambda is here as well with the alternate angles. And by the way, since this is theta, this is 90 minus theta and 90 minus theta is here, both are 90 minus theta. And by the way, 90 minus theta with 90, here you have theta. Now you can even more clearly see the code rule. You can say applying code rule for ABC triangle. Applying code rule for ABC triangle. There you can see L plus L cot 90 minus theta. Code rule. L plus L cot 90 minus theta. L plus L cot 90 minus theta. By the way, they haven't given angle of friction tan lambda angle theta. So to deal with trigonometry, there is one mistake I have done. The mistake is in giving those trig expressions, we have to deal with radians. So don't mark it as 90 minus, mark it as pi by 2 minus. So it should be pi by 2 minus theta, not 90 minus. That is the thing. Even though they haven't given, deal with the radians. Right, L by L plus L got pi by 2 minus theta, L by L plus pi by 2 minus theta. You have the upper angle, so you have to have the product from the other side where you, I mean, other than the side you have considered the angle, the side angle. So it is L cot lambda minus L cot theta equals L cot lambda minus L cot. Now you have to target towards your answer. There, this is L plus L, this is going to be 2. So 2 cot 1 pi by 2 minus theta is tan theta equals cot lambda minus cos theta. By the way, they have given everything in terms of sine and cos for tan lambda. So let us make tan lambda the subject. There obviously cot lambda is 2 tan theta plus cot theta. So let us solve for cot lambda. Then we will have tan lambda is 2, making everything to sine and cos plus cos theta over sine theta. Then LCM sine theta cos theta 2 sine square theta plus cos square theta is cot lambda. Next, so the tan lambda is this. Tan lambda is the reciprocal length. At the same time, by looking at the question, I have sine 2 theta. So I'm multiplying both the sides with 2. So it is 2 sine theta cos theta over 4 sine square theta plus 2 cos square theta. By the way, in the denominator you have cos 2 theta. Right? So tan lambda equals sine 2 theta. Power reduction 4 sine square theta. Oh, other than that, you can do this as well. Cos square theta is 1 minus sine square theta. So you have 1 plus sine square theta there. So it is going to be 1 plus sine square theta. Since cos square theta is 1 minus sine square theta. Then by multiplying with 2, it is going to be 2 plus 2 sine square theta. After multiplying with 2, right? 2 plus 2 sine square theta. So here you have 2 plus 2 sine square theta is 1 minus cos 2 theta by 2. So the final answer therefore tan lambda is sine 2 theta over 3 minus cos 2 theta. Sine 2 theta over 3 minus cos 2 theta. That is how you need to have that answer clear. So please do the corrections. If you have any question, please ask. Power reduction is correct, ne? Because in power reduction, I made that cos square theta to 1 minus sin square theta. So altogether, it is just 1 minus sin square theta. I multiplied both sides by 2. So 2 minus 2 sin square theta. Sorry, 2 plus 2 sin square theta. Yeah, then sin square theta is 1 minus cos 2. All right, so now let us do the vector question. Question number 7. Question number 7. In question number 7, we are revising vectors. There, in the usual notation, let 4i plus j, lambda I plus mu j, and I plus 5j be the position vectors of the two 3 points A, B, and C. You have to know that the position vectors are, they are with reference to O. So position vector of A is OA, B is OB, C is OC, likewise. So you have to introduce their data in this way. Here, OA equals 4i plus j, 4i plus j. You don't need to highlight, you have to underline these i's and j's, which are the respective unit vectors alone, x and y axis. Lambda I plus mu j is OB. Lambda I plus mu j is OB, then OC is further I plus 5j. I plus 5j. Right. Then they say where lambda and mu are positive constants. Now that is something to note. Lambda and mu are positive constants. Then the diagonals of the quadrilateral OABC are equal in length and perpendicular to each other. Quadrilateral OABC means that what are the diagonals equal in length and perpendicular to each other? OABC, so it is OABC. You don't need to close the quadrilateral because you need the diagonals only. O, A, B, C. So the diagonals are AC and OB. Those are the diagonals, AC and OB. Uh, write down AC in terms of I and J. So let us start. AC. So to have AC, you cannot directly have AC. By the way, you have to use triangle law of vector addition. So you have to mention that AC is AO plus OC as an addition. So you have to say by triangle of vector addition, AC is going to be AO plus OC. So AO is the negative vector. So minus 4i minus j plus OC is plus I plus 5j. So minus 3i plus OJ. That is AC. That is AC. Further, AC is done using scalar product so that lambda is 4 and mu is 3. Lambda is 4 and mu is 3. By the way, AC is done. You know AC and OB is there as well. Uh, Since they say equal in length and perpendicular to each other, yes, you have to use the scalar product to solve this. By the way, first of all, it is about the connection between the lengths. So you have to say it's in modulus of AC equals to modulus of OB. It is not just the vectors but the magnitude. They say the diagonals are equal, that is why. So AC modulus in IJ notation, components notation, it is 3 squared plus 4 squared root equals OB is lambda squared plus mu squared root. So lambda squared plus mu squared is 25. Equation number 1. Further, now scale product. By scale product, it is OB dot AC is 0. Because of that, OB is perpendicular to AC. That is why. So the dot product is product of the modulus or the magnitudes into cos angle within, I mean the in between angle. Since it is 90, cos 90 is 0, that is why. So what about OB? Lambda I plus mu j dot AC minus 3i plus OJ is 0. So minus 3 lambda I dot I plus O mu j dot j is 0. So minus 3 lambda plus 4 mu is 0. 2. Now it is pure math. Solve 1 and 2 simultaneously because you have shown that answers. No, I'll give you some time. I mean, those who have done, you can like refer to the answer and compare the methods. Those who haven't done, so I have like given to 90% of the answer. You just have to simultaneously solve 1 and 2 to have those sums. Do it, please. Right. So what you have to do is the possible thing is you can also substitute from 1 to 2. By the way, as 2 is linear, lambda and mu. In 1, it is, I mean, in the quadratic form. So it is better to substitute from 2 to 1. So either like 3 lambda is 4 mu, lambda is 4 mu over 3 to here, or 4 mu is 3 lambda, so mu is 3 lambda over 4 to 1. Then by using that, you can solve, right? So I'm not going to solve since you're okay with that now. I'm going to directly go for the question number 9. Question number 9. Question number 9. In question number 9, it is VT graph, right? So the front of a train moving on a straight track passes a signal post with velocity u, and later its rear passes the same post with velocity v. So it is about, so let us say this is the signal post, front passes with u, so uh, the back or the rear passes with v. So as it passes from u to v, let us say the time taken is t. They are even given, yeah. So that is going to be the, as signal post is considerably nothing when you compare it with the train length of the train. So for that t time, I mean the distance train has traveled is equal to the train length. That is what the total time taken to pass the post is t. Show that in t by 2 time from the beginning, part of length of the train has train passed this point. All right. So let us take the VT graph, velocity time, velocity time. Here u to v, u, and this is the time they have given a capital T. All right. Then they haven't. You certainly know that the train is accelerating, but they haven't given. By the way, the acceleration or the deceleration. Further, the total time taken is t. Show that in t by 2 from the beginning. Yeah. By the way, you have to have the total length of the train. Find out the fraction name. So let us have the total length of the train by evaluating the appropriate area. I'm naming this as A, B, C. So you can have length of the train by evaluating the area of OABC shape, which is a trapezium. You can say length of train equals OABC area. So that is going to be uh, area of trapezium, sum of the parallel sides into the perpendicular height divided by 2. So that is going to be q plus v into t by 2. So that is the length of the tree. And you can say that is capital L. Capital L. Now at the time t by 2, you have to find the length, then the fraction t by 2. For the t by 2 time, it has marked the velocity as v1, and that particular data is ABC, B is A, is B, and this is B. Alright. By considering the gradients, you can find the value of V1. So you can say considering gradient, you don't need to name the acceleration. Just have to say considering gradient here. That is going to be V minus V1 over T by 2 equals V1 minus U over T by 2. And theta obviously, right? So V minus V1 over T by 2 equals minus U over T by 2. There, 2V1 equals V plus U, V1 equals V plus U by 2, V1 done. Now you can find, um, you can say distance traveled at T by 2 time equals, what area is there? This OA, you have to name another letter. Let us say this is F OAFE area. OAFE area. That is also trapezium. Yeah. U plus V1 into P by 2 by 2. U plus V1 into P by 2 by 2. So U plus, what about V1? V plus U by 2. V plus U by 2 into P by 4. By the way, that is U plus V into T by A. Let it be L. Therefore, now the portions. L by L. I mean, they say part of the length. So part of the length means that you have to have that particular part which has been traveled by the train in that certain time over the total length of the train. So that is LOL. That is why exactly I have named those as L and capital L. Then I can finalize my answer with. That is why. So U plus V into T by A over U plus V into T by 2. It is 4 equals U plus V over 4 into U plus T. That is one. U plus. Is that clear? That is the answer. 3U plus V over 4 into U plus. Obviously, you will have one VT graph question for short questions and half of the essay as 11 name. So you have to get ready. Please revise the things and yeah, do the corrections. All okay? Right. Now, question number 5. Question number 5. So actually, I haven't published about the paper class. Now, I mean, it is just the first day. So next week onwards, we have to gather like more students after publishing. So you can also give the message to your friends. Let's see. So this is just that the first paper. Next week onwards, we will do more work and gather more students because by coming to this paper class, you can revise everything in combined maths, both in PO and applied. Um, you can have the paper before to the paper class and time it and do it. In the discussion, you can ask any question. Like any doubt you have, you can make it clear further. Right. Question number 10. Question number 10. It is regarding to work and power. Question number 10. A lorry of mass m kilograms with its engine working at the power h kilowatts has maximum speed of u meters per second on horizontal road. With the engine working at the same power, the maximum speed of the lorry up a road of inclination beta to the horizontal is v meters per second. If the resistance is unchanged, find the value of h. Find the value of h. Then what you need to do is you have to have the resistance. They say if the resistance is unchanged, that is exactly why they have given two conditions. Firstly, the horizontal road, and secondly, the inclined road. Then to apply the resistance for the inclined road, as they say, the resistance stays the same. You have to find the resistance by using the horizontal road. Is that clear? Right. So let us use the things for the horizontal road first. So this is the object in kilograms, and we mark the tractive force and the resistance. I mark tractive force as F1 because for the next one I need to have another tractive force, but the resistance stays the same. That is why R. All right. So it is u meters per second, the steady speed or the maximum speed, by the way. So it is steady. You cannot accelerate more than the maximum speed according to the power you have in your engine. Right. So you can apply H equals PV. Applying equals OP equals infinity equals PV, then it is going to be they have given the power as H kilowatts. So H into 10 to the power 3 watts going to be F1 into 2 meters per second. F1 is going to be 1000 H over U newtons. Number one. Then by applying F equals MA, applying F equals MA towards right, you can say F1 minus R is M into no acceleration since it is the maximum speed. F1 is R, that is 2. Then you don't need to even name that as 2. Therefore, you have to say F1 is R no, so therefore R is 1000 H over U newtons. 1000 H over U newtons. All right. Then further for the next, that is going to be beta. Going up near the AC. Going up near. Lorry up. There the maximum speed is V. So there it is V. Maximum speed. Alright, then here it is better to mark the weights because you have to further deal with the component of the weight here. So here I'm marking F2 as the active force, R as the resistive force. So here also you apply H equals PV. Apply H equals PV, then it is going to be H into 10 to the power 3 watts equals F2 into V is V meters per second. Then F2 is 1000 H over V newtons, that is 2. Correct? Now we apply F equals NV. Applying F equals NV is inclined beta upwards. So it is going to be F2 minus mg sine beta equals NV into 0. So F2 you know 1000 H over V newtons minus R is 1000 H over U. 1000 H over 2 Newton equal mg sine beta. Mg sine beta. Right, you have to find h now. So h is going to be here in mg sine beta, it is kilograms, right? No, kilograms, it is Newton. It is Newton. Newtons for newtons for newtons. So you have to have LCM here before making the subject h. Du, 1000 h can be taken out. Then u minus v equals mg sine beta. Therefore, what is h? Mg uv sine beta over 1000 h into v minus u. That is h. The value of h, they have recommended h with the units. So in finding h, no units is there. H is always, already recommended for the units. So it is just a value. Clear? Right. So ask any question if you have. Now, by the way, you can do the corrections. Yes. All right. So I'm going to continue with question number 12, integration. So each of the week, I'm going to try the different questions. I'm going to skip differentiation. We have 2.5 hours for the class. By the way, for the next week, I'll include 4 different questions. Then after that week, when I include again differentiation, that is going to be the differentiation. Likewise, right? So you have your part as well. So I'm like picking by observing the answer sheets. I mean, more into the hard questions. Harder questions as students didn't answer, haven't answered, right? That is one. Question number 12, integration. Question number 12, integration. By using partial fractions, integrate. So you have to first go for the partial fraction. You have to say by partial fractions, x squared plus 1 over x plus 1 cubed x minus 2. X squared plus 1 over x plus 1 cube x minus 2 equals to partial fraction a over rules x plus 1 cube plus b over x plus 1 squared plus c over x plus 1 plus d over x minus 2. Alright, introduce ABCD as positive constant. Sorry, as real constant. We don't know whether they are positive or negative. By the way, multiply everything with these, and at the same time, you have to mention the domain that is better. Here, what is the domain? X cannot be minus 1 or 2. That is the domain. In this, this is a fraction or an expression, or in particular rational function, you have to give the domains. Being multiplying everything with x plus 1 cube x minus 2. So x squared plus 1 equals a into x minus 2 plus b into x plus 1 x minus 2 plus c into x plus 1 squared x minus 2 plus d into x plus 1 cube. Right, in the next step, I'm going to arrange everything into the descending order of powers of x. So it's better to write this down in this way. X squared minus x minus 2. Here it is x squared plus 2x plus 1 altogether. X cubed minus 2x squared plus 2x squared. Then minus 4x plus 6 minus 3x minus 2. What about this? X cubed plus 3x squared plus 3x plus 1. Alright. So in the next step, x squared plus 1 equals uh, c plus dx cubed. A plus bx cubed squared bx squared plus 3dx squared excess a minus b minus 3c plus 3dx. Then constants minus 2a minus 2b minus 2c plus d. Alright, so let us compare. By comparing coefficients, at the start it is c plus d. Right? So e plus d is 0, 1. That is by x cubed. X squared b plus 3d is 1, 2. That is equation number 2. Comparing x's, a minus b minus 3 plus 3d is 0, 3. Constants minus 2a minus 2b minus 2c plus d equals 1. That is 4. That is 4th. Right? It is going to be the 4th. Now, in solving this, that is going to be the better option. Here you have C and D, here you have B and D. I can get rid of D to have B and C only. And it's minus B. Yeah, for D you can go for C and B for everything. Right? So in terms of C and B for everything. So you can see by 1 and 2 to 3 and 4. See what we can do. So B is minus C here. B is minus C means that the third one can be updated like this. Minus 3C, D is minus C, minus 3C, minus 3, minus 6. D is 0. D is updated. For the fourth, D is minus C. D is minus C. And by the way, we have an issue with that. It is not to go like this, but this is better. Let us put C in terms of D and B in terms of D. Then you can solve for A and D. That is better. So C in terms of D and B in terms of D. C in terms of D minus D. So it is plus 3D. Be like this. A minus D minus 3. C is minus D. Right? 3D. 3D and that is 3D done. 3D is here. And you have to replace B as well because our target is this is like a bit complex, right? So my target is to keep A and D only by substituting to B and C respectively from 1 and 2, right? So A minus, what is B? 1 minus 3D. 1 minus 3D, right? Minus 3C. Minus 3. C is minus D. C is minus D. Plus 3D. Plus 3D. Is 0. Is 0. There is 0. There. Uh, plus 3D plus 3D plus 3D plus 9D. A plus 9D equals 1. So 3 is updated. You don't need to name it in another way. Or even you can 5. Right? So the next minus 2A minus 2A minus 2. B is 1 minus 3D. Right? Minus 2C is minus 2. C is minus D. Plus D is 1. Clear? There minus 2A is here. Then plus 6D plus 2D plus 8D plus 9D plus 9D equals minus 2 and plus 1 plus 3. That is 4. You can right away go for A by 3 minus 4. You can say 3A is going to be minus 2. A is going to be minus 2 by 3. So what is D by, so let us say by 3, 9D is 1 minus A. 1 plus 2 by 3. D is going to be 5 by 27. That is D, 5 by 27. Further, C is minus D by 1. C is minus D. Minus 5 by 27. What you have to have now, A done, D done, C done, D. D is 1 minus 3D by 2. B is 1 minus 3, 5 over 27. So there you have 27 minus 15. So 12 over 27. 12 over 27. Clear? Now let us update. You have like continue. I'm going to erase here. So after that you can say now. Now after everything. Now A we found A is minus 2 over 3. Minus 2 over 3. B found B we found as 12 over 27. 12 over 27. C as minus 5 over 27. Minus 5 over 27. D as 5 over 27. 5 over 27. Right. So now we have to integrate, but before that, can you please do the corrections on the partial fraction? Then I'll support you to integrate. Please do it prior to the integration. Thank you. Apart from the integration. So I told you that this is one of that hardest question model you can be given. According to the partial fractions. Normally in partial fractions that the integration part is not that hard. That is the key. Right. So in integrating, you can apply the integration to both the sides. X squared plus 1 over x plus 1 cube into x minus 2 dx equals, take minus 2 by 3 out, then it is x plus 1 to the power minus 3 dx. 12 by 27 now, then x plus 1 minus 2 dx, then minus 5 by 27 now, 1 over x plus 1 dx. I'm accordingly changing the pattern, right? So plus 5 over 27 now, 1 over x minus 2 dx. Right here, minus 2 by 3, x plus 1 to the power minus 2 over minus 2, plus 12 over 27 into x plus 1 minus 1 over minus 1. Then minus 5 by 27 ln x plus 1 plus 5 by 27 ln x minus 2. Here 2 to 2. So 1 over 3 into x plus 1 squared minus 12 over 27 into x plus 1. 27 into x plus 1 plus 5 over 27 plus 5 over 27 ln x minus 2 over x plus 1 plus c is arbitrary constant. That is going to be the final answer of the integral. Yeah. So again, I'll revise you the methods I've used. The power rule. That is why I brought x plus 1 cube to the up, because for the power rule that is x to the power n the format, right? Then I used for 1 over a linear, that is log rule. That is log rule. So that is why I kept 1 over the linear as it is without bringing into the top. Clear? So it is like, I mean, you can just follow partial fractions, and there's the simple rules in integration to even complete the partial fractions integration question. So let us say they are allocating 50 marks for you out of 150. So let us assume that it depends. Some of these they have recommended 50, some of these 40, likewise. I mean, it is about the weight of the question. By the way, so let us say that is 50 out of 1000, out of 100, that is 5 marks. How much valuable is that? I mean, even without going to the by parts and the substitution. Right. Now I'm starting by parts. By parts question. By parts question. Question number 12, part B. There you have part B. There you have method using by parts, even they recommend. By the way, it is by parts because it is product of two functions. So x tan inverse x squared dx. You know that it is always better to go with a notation to make the steps lesser, right? Here you pick, that the v, which is out of these two, the function you can integrate, even though you don't choose x when the other function can be integrated by here. But here, tan inverse x squared cannot be integrated, so you have to, by the way, choose. Anyway, choose x. I equals tan inverse x squared is here, d by dx, the integral of x, which is x squared by 2 dx. Now LHS is arranged. Now to the RHS, x squared by 2 into tan inverse x. I'll be introducing everything again. Tan inverse x squared minus this is out and this is in for d by dx. Tan inverse x squared dx. Further, I is going to be x squared by 2 tan inverse x squared minus half out x squared into this is 2 tan inverse x, chain rule. Tan inverse x squared should be differentiated with respect to tan inverse. In 2 tan inverse x, then tan inverse x with respect to x into 1 over 1 plus x squared, or x squared plus 1 into dx. Now let us take squared by 2 tan inverse x squared. Now let us take nothing to take out. X squared tan inverse x over x squared plus 1. Now you have to handle this carefully. X squared tan inverse x over x squared plus 1. So, yes, you don't have any formula or nothing. So, you again, it is like you have to use by parts. There, you don't know how to integrate. By the way, x squared over x squared plus 1. You can, but by a formula, you don't. Tan inverse x also, by a formula, you don't know. It is by parts, you know how to integrate. So, what you are going to do is you can like do this. Just make this as d, right? So, there, these three. You're like, how can I even think this? That is like the practice, right? So it is x squared tan inverse x squared by 2 minus. For these, you have to use a trick. For x, I mean, we are using this trick where we have the rational functions. When we need to integrate rational functions. So this is it. This is it. For this x squared, you have to do plus 1 and minus 1 over x squared plus 1 tan inverse x dx. Thereby, you can clearly see something you can evaluate. X squared plus 1 over x squared plus 1 is 1. 1 into tan inverse x is tan inverse x integral. Tan inverse x integral. Then minus 1 over into plus 1 over x squared plus 1 tan inverse x. So can't you evaluate now? Tan inverse x to the by parts again. 1 into tan inverse x. You can do it by using by part. Here, it can be done like in previous 1 over x squared plus 1 and tan inverse x. Fx f dash x. That is it. The next step, you can integrate this. By the way, to integrate this, you have to again use the by parts. I'll write it down here. By parts. Here, fx to the power n f dash x. Is that clear? So after so many lessons, it doesn't matter the time we invested on this. So it is worth. You can like now see that is it. But you, I mean, you have to have that thought here. Plus 1 and minus 1. Otherwise, it is like we are like doing the hard work again back to y. Doing all the hard work again back to y. Why is that? We kept using the same thing as for the derivative and integral for respective for tan inverse x and 1 over 1 plus x squared. The same thing repeated and repeated. So they have like considered all the mistakes students can do in making such a question. So when they need to make the paper really harder, they will put such a question for sure. So you have to practice for the hardest paper. No? That is why. So please complete this. Then we'll be going for the other question. If you have any question, please ask. All right. So any comments regarding to the answer? Did you do? I mean, have you done uh, any questions which is harder than this in past? I mean, once you always have those techniques to, I mean, once you always have the practice, you have nothing like the hard questions with inside the syllabus. By the way, have like done before such a question? You have to be tricky here. I mean, we have met the questions like we have to do the by parts again. We have to go for the symmetry like exponential and trigonometry, and likewise or substitution even. But here is like totally different. You have to be tricky here. You have to like think, this is what I need to do. For that, you can't think. Even if you are the best meter, it is like you can't think once you. I mean, if the exam is the first time you experience this question, no, you can't. You have to practice before the exam. That is why, right? All okay. Now the next part C. By the way, I'll try my very best to increase the class time because I feel like it's not just like I'm writing down the answers on the board. Not this is not a conventional paper class. I'm writing down the answers on the board. Then let you write down them. I'm like discussing. I'm also trying. I'm also like being a student here. That is how we need to understand our mistakes. Just by writing down my answer, I can even look at the book or something for the answer and write it down on the board. No, that is not successful. Before going to the exam, you have to understand all your mistakes for all the questions, for all the question models, and to understand the very correct path as well to save your time and everything. That is why, for that, being a conventional class, I can like be limited to 2.5 hours, but I'll try my best by managing my time to increase at least 30 minutes next week onwards for the class, right? All right, part C. Part C. In part C, they say prove that. So that is that well-known equation in substitution. In proving that, I'll support you to prove. Uh, Again, when we meet this, I'm not proving. So you have to grab it from here. So you have to prove 0 to a fx dx is 0 to a if a minus x dx. There you have to take this as I. Take that as I. You can use I because that is a different part. For B also we used I, but C is different part. So you can again try. So now I equals 0 to A, F A minus 6 D. So you have to substitute. This is the formal substitute. I mean formal proof. Substituting A minus X equals T. There you have to differentiate with respect to X, let us say. So minus 1 is dt by dx. Dx is minus dt. Dx is minus dt. So the limits when x equals 0, when x equals 0, t is a. T is a. When x equals a, t is 0. Now you can update I. Now I is a to 0 ft minus dt. You know that you can keep like this forward. By the way, you can exchange this minus with the limits by changing those. So I is going to be 0 to a ft dt. By the way, after this, it is about properties of definite integration. Doesn't matter if it is both. If it be t or x or something, it is about like replacing, not substituting. You can say same way. It doesn't matter the input. I is 0 to a fx dx. 0 to a fx dx. Proof. You started with here f a minus 6, end up showing the other part. Clear? So if you have forgotten now anything, I mean, if you need to get these corrections, let's get it done now. Then we will go for the question. All right. Next part. Hence show that. So that is a well-known question model. If you have done number of past papers and the model papers, doesn't matter the model papers. Even if you have done number of past papers, yeah. By the way, even if you are beginner, if you are a beginner to the papers, still you can get this. Don't be demotivated, right? So in the very next step, in approaching for the hence part, it is this. To have the approach for the hence part, it is this. Ensure that if I equals, also I equals me. So let us start. The I they have given is 0 to 5 by 2. 0 to 5 by 2. X sin x cos 6 over cos 4x sin 4x. Cos 4x plus sin 4x dx. All right. This we covered by the way. So this is what you need to do. You know that from that model, when you integrate the function from 0 to b, it is as same as when you integrate the function from 0 to a. By the way, the input should be upper limit minus x. So here you can see by the above result 0 to 5 by 2. All the x's should be replaced by a minus. I mean, here it is 5 by 2. So it is 5 by 2 minus x, sin 5 by 2 minus 6, cos 5 by 2 minus 6 over cos to the power of 4 5 by 2 minus 6 plus sin to the power of 4 5 by 2 minus 6 dx. Further, this is sin x, sorry, cos 6 90 minus 6 means sin x sin 4x cos 4x. By the next step, it is 0 to 5 by 2 5 by 2 minus 6 cos 6 sin x over sin 4x plus cos 4x dx. Now, yeah, in this model, this is also very like usually coming. You can separate this. It is like this. A minus b into c is ac minus dc in the same way. You can expand everything with 5 by 2 and everything with minus 6. So I is 5 by 2 into cos 6 sin x over sin 4x plus cos 4x dx minus, so that is 0 to 5 by 2, 0 to 5 by 2 x cos 6 sin x over sin 4x plus cos 4x dx. So continuing, I is, what about this? It is about, I mean, you don't know anything about it by. So let us keep with that. Cos 6 sin x over sin 4x plus cos 4x dx minus, this is again back to I. It is that symmetry we expected before. Before we didn't have. Now you understand the reason. So going forward, 2I is this. So I is 5 by 4 divided by 2. 0 to 5 by 2. What you have to show? There you have tens. To have tens out of cosine sign, get everything divided by the maximum number of coses, cos 4. So cos 6 sin x by cos 4, cos to cos cancelled off, sin x over cos 3, sin x over cos into 1 over cos squared, tan makes sec squared dx. So you can see dividing by, please mention that, otherwise you don't know it, dividing by cos 4x. In here, tan 4x plus 1, tan 4x plus 1, 1 plus tan 4, tan 4x dx. All right up to there, ne? All right up to there. Everything is great. And they have given, even after that, a substitution for a show that. The substitution for a show that. So let us use that substitution, which is I equals, sorry, t equals tan x. Ne? So you can say substituting t equals tan x. You have to differentiate to get dx to dt. So you can say differentiating with respect to x. dt by dx equals x squared x. dt by dx equals x squared x, obviously dt x squared x dx. Now you can go forward. Now, before that, adjust the limits as well. When x is 0, t is 0. when x is 5 by 2, t tends to infinity. There you have to be careful. I is, you have to use a limit. Limit n tends to infinity because you cannot put infinity there. N to 0, 0 to n. Again, limit for the integral. And yeah, tan x is t, sec squared x is, sec squared x d is obviously is d over 1 plus tan 4d. So it is going to be t4. T over 1 plus t4 dt. What do you think now? Can you suggest me a method? Like, right. So do up to here and please suggest me a method because by looking at t over 1 plus t4, it is a rational function to integrate. A rational function to integrate. Um, in integrating a rational function, it is f dash x over fx, the first option. No, not matching. Partial fractions, not matching. 1 plus t4 cannot be factorized further. Lone division, no. The upper degree is low, but this cannot be divided. So what is this? Please suggest me a method doing up to here. Start. Any suggestions you have? Any suggestions? The thing is this. Since we have nothing, it should be either by parts or substitution again. It doesn't look like by parts. It is substitution again. See how I told that substitution. Yes, I thought they have given the substitution for the first stage. So we have to buy ourselves. I mean, strategic use a strategic move on this to finalize. So by understanding that by parts is not appropriate, here is substitution again. Obviously, you have to think about 1 over 1 plus x squared here. Oh, by any means. So it is going to be t squared equals u. As you have been with x, don't use x again. T squared equals u. Substituting t squared equals u, then you can say differentiate with respect to t. 2t equals du by dt, du equals 2t dt, and the limits. When t equals 0, 2 is 0. So when t tends to infinity, u also tends to infinity. You can see now I equals limit t tends to infinity. Sorry, u tends to infinity now. Previously, no, that is about the limit now. So as you cannot put right away infinity here, it is not a number. Again, you can use n, it doesn't matter. N tends to infinity, n to 0. It is going to be t dt is, yeah, du by 2. So take half out, du over 1 plus u square, which is well known formula, and tends to infinity. Half out, half right away out from everything. Um, and this is tan inverse u 0 to n. So half out, tan inverse, it is like infinity. So that is going to be pi by 2 minus tan 0. Finally, pi by 4. But they request 5 squared by 16. Wait, where we have to like modify the answer from there. Pi by 4 is there. We miss that. Here onwards we miss that. So pi by 4. Pi by 4. Before to I make pi by 4. So here also you have pi by 4 half out. So obviously 5 by 8. So this is 5 by 8. This is 5 by 8. Now 5 squared by 16. That clear? That is it. So good suggestion you made. That is the experience. I mean, with your meter, you have to also use your motor. Motor is about the experience. Meter is about the skill where you understand the things. To for that you have to have passion towards math. That is why exactly you have chosen maths as well. So you all have the skill. It is about the motor. It is about that practice you have to make before going to the exam, right? That is it. So yeah, as I promised you, in this week I'm going to publish the class further. You can also inform your friends. I'm going to extend the time as well, right? That is a better thing for you. Because I experienced today, as per my method, this is my method. I always teach, possessing being a student. Otherwise, I'm not writing down the answers on board. I mean, referring books and everything. I don't refer uh, anything in the classes or in the paper classes or anywhere. So it is about my knowledge. So I'm like utilizing my knowledge. Uh, in the class live. Uh, So to give you that lesson and the experience there, but how you have to be prepared before the exam. That is the thing, right? So there I'm making all that good standard questions from the exams, from the model papers, the government papers, and everything. That is it. I told you that I'm not referring to books or anything. That is for teaching. Otherwise, for all the other knowledge, obviously, to update the knowledge, even I'm also learning to give the better teachings to you. By the way, so that is about it. I'll keep informing you about the class times and everything. For the next paper, I'll be giving you before the paper, and you have to get it done within the given time and be prepared for the discussion. All okay? Right. So for the new students, you can like give me the comment and send me further that what your continuation of the class. So soon I'll inform you about the further proceedings of the class, right? Yeah. So that is it. Please keep continuing with the questions because you have more questions. So today the time is limited. That is why. But if you have any issue, don't hesitate. At any time you can ask. But anything I haven't discussed, or even with the questions I have discussed. Okay. But I think goodbye. Bye bye.